Alrighty, folks, we are learning inheritance. There's a bunch of people outside on my patio working on the apartment. But this is going to be the last episode thing that we learn in the Solidity series, so it should be a good time, right? Like this has been a good series. We've learned some granular information about Solidity, and this could be our last part, hopefully. Well, hopefully not. Actually, I've really enjoyed the series as a whole. So let's dive in. I'm going to try to get as much as I can done in this one episode. I'm looking at the time. I do have a meeting with work at 9 sharp. So we might break it up to two parts. But let's learn about contract inheritance. Okay, so as with many object-oriented languages, Solidity includes inheritance as a feature. Inheritance means that you can create an object with some values, methods, and use it as a base for other values or other objects. So what that kind of means is we could have a class of, let's say, a class of a shape, or maybe even the class of like a house, right? And you can embellish on a house, right? So a house has a few things. It has like walls, maybe even that's too complicated. Let's say a class of a human. So we're all humans, right? So this is a good example. So I have a name, maybe a social security number, maybe some basic demographics, height, age, things like that, right? But let's say humans as a whole, we have a set of things and functionalities. So maybe one of our methods and functionalities would be like go to bathroom, right? But then we can use that as a base case to then build the class on top of it. This is inheritance, right? So then I can build the class for Ryan or Pags. So I extend on the human class by saying, okay, he's a human. He's got these base characteristics and traits. Like needs water, breathes. Goes to the bathroom. Things like we all do that as humans, right? But then we can build on that. Now, the reason why for that is because let's say I'm building I'm inheriting the human class for defining me, which would be maybe we build another class that talks about my interests and hobbies. So I have a huge passion for programming and maybe working out. So maybe those are like two of my interests. And I have a huge passion for God. So that would be a third interest, right? Not really an interest, more of a omnipotent knowing for myself, but the other class, for someone else, you can maybe start with the class human, but then embellish on it. So let's just use some random name, maybe a gentleman named is Zach, and he has his own things that he's interested in. So the whole thing with inheritance is we could do a lot of the work and get the base case of, okay, knock off all the human boxes for this person. Done, tick. Tick, 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 boom, done. But then if we want to inherit and build something on top of that, I can now use the human class to build, this character set of Ryan in this database, and then I could do the same thing with Zach over here. I hope that kind of makes sense. We're going to dive more into it. So in Solidity, the objects we're referring to are contracts and interfaces. We can write a contract with state variables and functions. Then we can create contracts that inherit those variables and functions. These derived contracts can then choose to add behavior as necessary. So we're going to do all that in Solidity, right? So that was just kind of a big bird's eye view of inheritance using this like base case of human and then building people on top of that, right? Now with Solidity, obviously we could do, here's my ERC20 token, right? Here's a class of it, but then here is actually what its use cases and functions and methodologies are. So which might be different from this ERC20 token, but they're both cryptocurrencies, right? So let's keep reading. So this use case may seem quite similar to libraries. Just libraries, code reuse is a big motivation for inheritance. We don't want to repeat the work. Basically, we're engineers. We're not trying to overwork ourselves, right? So we'll take a look at why inheritance can be more powerful or a more powerful feature than libraries. Of course, that power comes with trade-offs. So with time and practice, you'll be able to understand these trade-offs and figure out which tools is right for the particular job at hand. Let's start coding. This is going to be a good time, folks. This is going to be a good time. So traditionally, inheritance is when one class copies or inherits functionality from another class. Throughout this lesson, you'll see terms base and derive. Simply put, the derived class inherits from the base class. So again, in that example, I imagine what we're going to do is the base class would be like human, most generic of the classes, and then the derived is going to be I imagine the class that's a little bit more granular, that's built on top of that human class, or the ERC20 token class would be the base one, the derived. I believe that's what I'm reading here. So, okay, so let's keep diving in. For Solidity, we'll be talking about inheritance for contracts instead of classes. And however, the concept is still the same. It's quite easy to inherit contracts in Solidity. Let's see an example. So we have a base contract right here, and boom. So this base contract has some functionality of value. We could change that value within this base contract. And then right here, you could see right here, this is the nuance. So class derived is base. So I don't know how many ears are React developers, but with class components, we're actually used to this. Is React component, right? So on the front end stuff, but because right here you define your front end component, and then you say is React component, right, or React FC, and basically this is already, we can access all of these things right here. So we have access to that scope if we do this. We're basically connecting it. We're building on top of it. Boom. So we've already started with the base. Here's the base. And now we have this derived contract we're building. Now we can start doing other things. So in this example, the derived inherits both the value storage variables as well as the change value function. Setup inheritance, all we need is the is keyword in the contract declaration, which specifies which contract to inherit from. Okay. So the body of the change value function is actually copied into the derived function's bytecode. So this is all the way down to bytecode. Interesting. When inherited, we can deploy. Sorry, I had to take a peek at the time. Let me move my face. So then when inherited, then we can deploy the derived as standalone contract with all of its inherited functionality baked into it. Cool. So you'll notice the superheroes.sol file imports the hero.sol file, the read-only file. Your goal is to create 2 new contracts that inherit the base hero contract. Create new contracts for mage and warrior, which inherit both the function and the state from the hero contract. So this is perfect because we just talked about something kind of similar. Let's build a human one and then build something a little bit more definitive on top of the human contract or the class, right? So now we're doing the same thing. We have hero, and boom, we're going to build something that starts with the hero functionality and just mage and warrior, it looks like. So let's go ahead and try to do this. So I can say contract. We got mage is hero, and boom. And I wonder if we need to import it. Oh, it's already imported right here. Let me zoom in a smidge for y'all. And we could go ahead and do this and say mage. And what was the other one that we need to do? Warrior. Great. Look at that. So I think that's all we need to do. Zoom back out. Sweet. To the next stage. Move my face back. Okay, so constructor args. Constructor inheritance. In the previous example, the base contract had a state variable with an initial value and a function to modify it. What if the base contract had an initial value that was set in a constructor? Interesting. So how do we handle constructors basically in a base contract? Can we pass the initial value into the base constructor when we're inheriting it? Interesting. Let's see. We sure can. Same syntax as invoking a function. So inherits everything from the base contract. So if we set the initial value to 10, looks like the constructor will still get active made out, or the value of this uint will be 10. So I'm seeing this as kind of a function right now at this point, as this class, right, is almost, this thing is just a bigger function that's doing a bunch of stuff, and we could pass it a parameter. So that's kind of how I'm seeing it in my brain a little bit, right? So see how we pass the 10 into the base contract? We sure do see the 10 right here, and that's getting set to the constructor when this contract is deployed. So this is provided as a constructor argument. It is possible, let me move my face, it is possible to send multiple arguments to the constructor as well. This is also a function syntax, comma separated arguments within the parentheses. So that's kind of what we just referenced, right? It kind of looks like a function. Okay, so our goal, our specific health, you'll notice that the hero.solidity file has changed on this stage. Now it has a constructor, which takes a health argument. Let's modify superheroes so that warrior has an initial health of 200 and mage has an initial health of 50. So what they had said, from my understanding, these are backwards, just from the question, the hero contract already has a constructor in it. So let's see. So let's view this constructor. Boom. Here's the constructor, right? So that's getting fired off initially whenever the contract is deployed. It's just a one-time function that gets fired off, and it accepts this health deal. So that's what we're passing in is 250. Let's move on. Okay, so virtual override. It's time to introduce two new keywords, virtual and override. Sometimes we'll want to leave a function on a base contract open to reimplementation by its derived class. Interesting. Okay, so that's where the two new words come in. The virtual keyword allows us to specify which function on the contract can be overridden by using the override. Okay, so I think what we could do is let's look at this. What I'm understanding reading this is we have a virtual keyword that we can indicate, okay, this function wants to override or be overridden. And this virtual function is part of the class, the human contract, if you will, the human class, right? So in this, we could maybe have a virtual thing, and then when we build the class for Ryan, right, the more specific one, the override, we now are saying, okay, it can override this specific function from the base class, from the fundamental one. That's what I'm understanding. Let's kind of look at this a little bit more granularly. So we have a base contract. So this method can be overridden. So we put the virtual thing on it. This is the now contract on top of the base, and we have the override external or the override keyword appended to it. So I don't think the function name matters. Just this keyword, I imagine, matters, and then the value that we're overriding. Or does it have to be the same exact function? That's something maybe we can test and try to break some code with. So in this case, both derived and base have different function bodies for increased value. The derived contract will use its own implementation of increased value, which overrides the virtual function implemented in base. The overriding function must have the same visibility as the virtual function. If not, the compiler will throw an error. Overriding function visibility differs. Okay, so keep an eye out for that one. So they both have to be external. If they're both external, we both need to match that visibility. Okay, so we can also specify abstract contracts where virtual functions do not require an implementation. Interesting. So it's kind of like proxy contract that you can mold and manipulate easily. Okay, so however, these functions must be implemented at some point by a derived contract. Let's take a closer look at abstract functionalities in the details. Let's do that. That's super interesting. Okay, abstract contracts can serve as templates for other contracts. They have a similar purpose to interfaces. Let's compare them. In an interface, none of the functions are implemented. There are simply the function signatures with no function body. Okay, so hold on one more time. With an interface, there's no implementation of the functions. They're just signatures with no body. So they just kind of give us the temp. An abstract contract, some functions may be implemented while others may not be fully implemented. You could pick those functions of which to implement. Now, I'm not sure how that looks. So let's keep reading, right? See if there's an example. I don't see an example. So implicitly, all interface methods are virtual. Abstract contracts must mark their methods as virtual if they allow them to be overridden. So I'm going to look up a contract here in a moment, an abstract one. So other than this, the abstract contracts are just regular contracts that can inherit from yada, 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 variables. Okay, so contracts can inherit interfaces, boom, boom, boom. What's the differences? They cannot have state variables or a constructor. The nitty gritty. When an abstract declares a virtual function without a function body, that function must be implemented by some non-abstract contract inheriting from it. It may be confusing to mention the non-abstract contract. Technically, an abstract contract can inherit from abstract contract, which can inherit from another abstract contract. So you could just keep going. It can keep going. None of these abstract contracts can be deployed only by all the implements of the function. Okay, so an abstract contract with unimplemented functions cannot be deployed. They must be inherited by a function which implements those functions. The derived contract which implements all the functions can be deployed. Okay, so let's kind of, if I'm getting lost in the words a little bit, let's just Google an abstract contract Solidity. Let's kind of see what's going on, right? So let me move my face. Guys, and we are going to have to do a second episode because I do need to hop on a work call. But okay, so let's see. So if a contract wants to create another contract, here's the source code of it. Let's see. Token creator. Maybe this is invoked here. I'm trying to look. Boom, here it is. Okay, so boom, we have token creator right here. We perform explicit conversion. So it looks this is just going to be initialized as a template. Maybe we can ask Chad real quick. Can you make a simple example of an abstract contract in Solidity, right? Can you make a Simple example of an abstract contract in Solidity. Boom. So let's do this real quick, and then I do have to wrap up. But I love the Solidity series, guys, and I'm working very intimately on some Web3 material. So please expect more. Please expect much more, because it is getting fun for work, right? I want to share more of it, and I'm going to do much, much better at doing that, because it is really cool what we are building. It is so fantastic, and I like have to share it with you guys. I have to. Okay, so define an abstract contract named base contract. So here's the abstract contract. Declare a function that does something, right? This function does something, but I don't see any like actual function brackets or parameters. So here's the contract that is being built upon the abstract base contract, the template, the abstraction, right? So we override the do something. Okay, and then finally actually have it do something. Got it. Okay, so that abstract contract is simply a template, is how I see. Got it. Okay, let's get back to our inheritance. Our goal. Oh, it looks like we do have a ton of stuff. Okay, but guys, I don't want to be rushed doing this, because when we want to learn Solidity, we want it to still really well. So let's come back around for the part 2 of this, and then that's going to be, I'm kind of bummed to say, but the last episode of this Solidity series. I've had so much fun learning about it, so kind of a bummer we're wrapping it up, but congratulations to everyone who ran through the whole course, or the whole series. And yeah, let's nail this last part and really understand inheritance, because Solidity is obviously keenly important with Web3 development. So I will see you on the next one.